All right, so today we're going to start the statistics and probability section, but before we do that, one thing I want to remind you about, because a couple of you are asking about it, the finance test, it is due tomorrow by midnight, all right, and it is not multiple choice. It is it's got random number generators in it, so when it pulls it up, you'll just have to use your financial calculator, use the websites that I showed you to help you get that figured out and get it calculated to the right values. Now I know that, like we said last week, the financial calculator and the websites, they may give you like different decimal places depending on how far they round out to. There should be a little standard deviation cooked into those questions, so that, like say, if you put in like 348.87 and you put in 348.92, and that's technically correct within the margin, should be fine. It shouldn't be that restrictive. But again, this is a test grade, so make sure that you get that done by tomorrow night at midnight. All right, now if you've already done it and you want to redo on it, remind me again on Wednesday, because that'll be when I start putting those in. Also, and I meant to mention this last week and I just forgot. If you have requested a redo from me and I told you I put it in and you did it, but your grade didn't change, one of two things happened. And I'm only mentioning this because I've actually seen this happen. You either got the exact same grade that you got the first time, or I forgot to update it. So just double check it, and if it says that you've gotten, if you've completed 2 attempts but your grade didn't change, make sure it's not because you got the same grade both times, or the more likely scenario that I just forgot to update it. I did try to get as many of those as I had a record of coded last week while we were on fall break, but it's hard to get them all. So just double check and make sure that that hasn't happened to anybody. All right. So we're going to start talking about statistics today. Now, a couple of things I want to go over. This is what we're going to be in for the next month or so. Hang on, let me get the pen thing ain't working right. There we go. Okay. All right. So yeah, this is going to be our next 4 weeks. All right. We're going to do statistics this week. We'll do probability and statistics, probability next week, and then statistics and probability the week after, and then we'll finish it up with a test. If we're lucky, we might be able to double up some of these somewhere, but I doubt it. Also, I noticed that on the schedule that I uploaded, like the yearly schedule, on this one and the 14-week, I had completely left out a week in November. Just completely forgot it even existed. So the new schedule now, the old schedule had us doing linear functions and then linear and nonlinear functions after Thanksgiving. We will now be doing it before Thanksgiving. And then after Thanksgiving is our last week of in-person meetings, and we're going to be doing the final review, both class periods that week. That way we're not trying to cram it all into one 50-minute class. And then that, like I said, December 2nd through the 10th, that's our last week of in-person meetings, all right? So make sure you put that on your calendar. So, yeah, that's all that really changed was I just completely forgot about the week before Thanksgiving. Either that or the more likely scenario, I forgot when Thanksgiving was. Sounds like something I would be guilty of. All right, I need you to open up 2 things, okay? If you've already downloaded the textbook file to your computer and you've got it saved, I need you to go ahead and pull that up. If you have it, go ahead and download that. If you're using one of my computers, I don't think that these wipe. So if you've already got it saved to that, you can pull it up on there too. See, like I've got it. See, I've got mine here on the desktop. So that way I don't have like 3 or 4 copies of it clogging up the memory. And then also go ahead and open up the PDF of the statistics notes. Now, these say statistics notes. We're kind of going to be using them for both statistics and probability. I think I've got a copy of them put in the probability section. I don't know for sure. We'll find out next week. So tune in next week, as it were. All right, we're going to start in the notes and go over some of this stuff. And if we can get far enough, we'll be looking at a couple of things in the book as well. Now, I know at the beginning of the year I said that we don't use the book for much, and we don't. We haven't. The last time we used the book for anything was in the conversion section, all the way back in section 1. So, but this section actually has some helpful stuff in it. So, statistics and probability is chapters 5, 6, and 7 in the textbook. Now, I'll just go ahead and tell you, with this level of statistics, I'm pretty much okay. But with probability, that's something I've always had to work at. It wasn't one of those things that just came to me like algebra did, you know. So I might make a few errors here and there, but hopefully we can catch them and get them fixed up. You know, nobody's perfect. Okay. The parts of statistics that we're going to be looking at, mean, median, and mode. Hopefully that's just a review for everybody because, you know, grade school kind of beats that to death. Box plots with 5-number summary. Is there anyone that does not remember or know what a box plot is? Okay, so maybe that'll be, for most of us, be a review too. They keep changing the name on that. For now, they're calling it a box plot. They used to call it a box and whisker plot, but you know, we'll get there. And then scatter plots. Scatter plots are probably the easiest out of these 3 things. Okay, so mean, median, and mode. We know that the mean is the average and that you get the average from taking the sum of the values, come on now, get with program, sum of the values and dividing it by the number of values, which means with a number set, you're going to take how many of them there are, put that on the bottom, and then the sum of all of them added up goes on the top. You know, a lot of the popular questions in grade school deal with, you know, homework grades or, you know, basketball scores, stuff like that. So, one thing to keep in mind with averages is that we have these things called outliers or extremes, and they really can mess with an average, okay? Whereas, if you have something like this next one, the median is just the middle value of your number set. Now, if it's an odd set, there will be a number sitting right directly in the middle of that set. And if it's even, it's kind of at the halfway. So you take the 2 numbers in the middle and average them up and you'll be fine. Now, before you do anything with mean, median, or mode, I forgot to mention this, the main thing you want to do is put them in order. All right, so I'm just going to write that in here. Put number set, it's running slow because it's not been turned on in a week. Put the number set in order before anything else. Okay. Now, with the mean, it doesn't have to be in order. You know, the mean is just kind of like throwing it in a blender. Everything's going to come out the same. But with median and mode, you definitely want to make sure that those are in order, because if you put them in order, for the mode, it'll just automatically spit it out. But with median, you can't do that one until you do put them in order. All right? So, back to my original point with the median. is that whereas the average is affected by outliers, especially if it's an outlier that's really, really below the majority of the numbers or really, really high, the median is not affected by outliers hardly at all, because the outliers are not going to pull the middle number one way or another. They'll pull the average either higher or lower, but they're not going to pull the middle number one way or another. That is why some statistical companies for analysis in recent years have started going to the median as their like indicating measurement as opposed to the average, because like think about it, if you work in like a company that is like in sales, you know, and then you have like a really high year, and then everybody, or like a really high month rather, and then all the rest of the months are just kind of about where you expect them to be. That one that's really high, or if you have another one that's really low, those two are really going to mess with the average, aren't they? But as far as the median goes, you know, median, you know about where you're supposed to be. Okay. And of course, mode is the easiest one. It's just if there are any recurring values, what is it? More often than not, though, you're not going to have a mode. So if you don't have one, you don't put 0. You put no mode. Now, you wouldn't think that I would have to highlight that, but I've seen that happen before. Someone goes through the numbers, oh, there's not one that repeats, and they say, well, there's 0 mode here. No, that's not how you say it. Because if you put 0 as your mode, what are you saying? That 0 is the one that shows up the most, right? Now, full disclosure, in checking over my grade book and everything, I have a couple of students where 0 is the mode of their grade. So now, you know, balancing that out, I have several that where, you know, 100 is their mode as well. Just saying, you know, they come in all shapes and sizes. Outlier. We mentioned that a minute ago. Outliers, or extremes as they'll be referred to in the box plot, is a value that is much higher or lower than the majority. It greatly affects the mean. It'll either pull it up higher or lower depending on how far away from the majority of the numbers it is. But it barely affects the median in the mode, if at all. Like we already mentioned, it's not going to really mess with the median much. The only way it's going to affect the mode is if you have 2 of them, or 2 or more of them. If like you have like say, you know, 8 numbers that are all ranging from like 30 to 50, and then you got 2 numbers that are 100s, those 2 numbers, first of all, they're outliers. Secondly, they're going to pull up your average. And thirdly, they're your modes, if none of the rest of them repeated, right? Okay, this was an example out of the textbook on page 371. I don't remember exactly what it was pertaining to. It might have been temperatures. I hope it wasn't test scores, but I think it was maybe temperatures. I'm not really sure. But the premise, regardless, the goal was, you know, find your 3 measures of central tendency, mean, median, and mode. So, again, before you do anything else, order them least to greatest, all right? Now, when I did these, typically, like say, if I'm assigned this question, what I'll do is I'll just start and I'll just go through and find them and mark them out as I put them in order from least to greatest, right? Well, I didn't do that with these because then the original numbers would have gotten harder to read. So I just underlined them as I went. So find the lowest number. It's going to be your 34. So there's 34. Then you got 36, 39, 43. And then there's 51, 53, 62, 63, 73, 79. All right. Next thing you need to know is how many of them there are. So I just wrote 1 through 10 across the top of them. All right. Now, if you don't want to put them in order until you get to median and mode, that's fine. I just don't want you to forget that you have to do that for median. Because if you don't, your median is going to be wrong. Okay, so for mean, again, take them all, add them up, divide by how many there are. I don't expect you guys to write this part out every time that you have a mean question. If you have 043, double check with Miss Wilson, see if she wants you to. You may have to for her. But for me, you know, as long as you can keep track of that in the calculator, it'll save you some time. So the sum of all 10 of those numbers is 533 divided by 10, and you get a mean of 53.3. Pay attention to the question in case it tells you to round it to a certain decimal place. Most of the time it's going to be to the tenths. All right, median. So this is the median of an even set, all right, because there's 10 numbers in the set. So what you do is you find the two that are in the middle, and then you just have to average them. Now sometimes you luck out and get ones like 51 and 53, which are consecutive odds, and you just know what's going to be between the two of those. So you don't really have to go through this. But like say if it was, you know, a really kind of wide-ranging number set and the two numbers in the middle were a 51 and 63. Well, then you would just need to go ahead and average it, right? So when you do that, it comes out to be 52. Now you don't want to say that 52 is imaginary, because an imaginary number is something completely different. I would say though that since this 52 is not part of the original number set, I would say that it's hypothetical. All right, you know what the median would be if it were present, but it's not. And then there is no mode of this number set, so just put no mode for that. All right. Hopefully that was a review. All right. Now if it were an odd number set, like say if out here you had like an 87 or something, and then that puts you at 11 numbers, then for the median you would just count them from the edges until you found the one in the middle. So 1, 2, 3, 4, 5. And then that means that 62 would be your median that way. All right. I've got a video in Moodle dealing with odd number sets, because when I went through these lessons the first time, for some reason every single example that I pulled had an even number set. And then of course all of the assignments I made had odd ones. Not all of them, but I mean they had several odd ones in there. So I just want to make sure that all the bases are covered. Okay, so box plots with a 5-number summary. What the 5-number summary is just the 5 numbers that you have to have in order to make a box plot on a number line. So they have names, each of them do. The first thing that you have is your lowest value, okay? Your lowest value, which can also be referred to as your lower extreme. That was what I learned it as when I was in school, was a lower extreme. Next, you have the lower quartile. Now what the lower quartile is, it is the median of the lower half of numbers. So after you find the median, then you can find the quartiles. So we already know that this is sort of out of order, or it's a particular order. We'll get to that in a second. All right. After the median, you have the upper quartile, which this is the median of the upper half of numbers. Okay. So median of the upper half of numbers. And then lastly, you have the highest value, which will be referred to as the upper extreme. Now, if you have to find the median before you can find your quartiles, why is it listed in this order? That is because This is your graphing order. In other words, after you have found these 5 numbers, that's the order that you put them on the number line with. That is not the order that you find them with, okay? So let me switch just for a second here. Oh, turn this off. Just for a minute. Okay, so that's the order that you graph them in, but the order that you find them in is different. All right, so box plots, 5 number summary. All right, so this is the finding order. Okay, so this is the order that you find those 5 numbers in. Okay, so after you put them in order, which that's that's important. After ordering the set. All right. So, first, you've got your lower extreme. All right. And the reason why that one is first is because when you put these in order from least to greatest, that's the first number that you're going to have. All right. The second one that you want to find is your upper extreme. Because when you put these in order, that's going to be the last number. So putting them in order automatically spits out the lower and upper extremes. All right? Then you've got the median is still in the middle. All right? And the reason why the median is still in the middle is because you cannot get the next 2 until you find the median. All right? So after the median, you've got your lower quartile, and then finally your upper quartile. Now I know it might be a little confusing having 2 different orders, all right? But if you try to find them in that order, it might, over on the screen, it may cause a little bit of trouble. So first, find them in this order and then just list them, all right? Lower extreme, upper extreme, median, lower quartile, upper quartile. You've got your 5 numbers. Then, when you go to graph them in that order over there on the screen, all right? I know it might be a little confusing, but today we're just going to try to get through the notes. Wednesday we're going to have some practice with these, okay? Because I just don't want to just throw you to the wolves, as it were. All right, so back to the computer screen. All right, so quartiles, again, are the medians of the lower and upper halves of your data after they were separated by the median of the whole set. All right, and again, I've got it in here in the middle to highlight its importance. The 5 number summary is found after the data set is ordered least to greatest and before building the box plot. All right, you cannot build the box plot without the 5 number summary. You can't find the 5 number summary until you put them in order. All right, put the data set in order. So then once we've got everything prepared, we're ready to build a box plot. All right. A box plot is a graphic that displays the 5 number summary on a number line. So going back to the problem that we had earlier, okay? So with this number set, we know that 52 is our median, right? But it's a hypothetical median because it's not part of the original number set, all right? So we've got these in order now from least to greatest, all right? So This is the graphing order. It's not the finding order. When I made these notes, I didn't have that finding order put together yet. I figured this would be fine, but it turned out that it wasn't. But too late to try to fix it now. So we've put these in order. Our lower extreme is 34. All right. And I'm just going to go ahead and go to the upper extreme too. Upper extreme is 79. We have our median from the previous example, and now our quartiles. Okay, so the median has now split this into two halves, the lower and upper half, right? In this instance, it made two odd numbered halves. So that is easy. You'll just find the number in the middle, call it your lower quartile, find the number in the middle here, call it your upper quartile. And then there you go. Now, if it was divided into even numbers, say like if you had 12 numbers in the set making halves of 6, you'd have to do the average in the middle thing again and figure it out that way. Still not terrible, but you know, could be easier. So we have our 5 numbers. We're ready to graph. All right. So I'm trying to remember the colors here. Okay, so can't think. Head hurts. All right. No, I've already got the graphing order over there. Whew. All right, so 34 is our lower extreme. We're going to put that on there first. All right. Next, we have our lower quartile, which is 39. I'm going to put that there. It's not the upper one. Shoot. All right. Then we got our median, which is 52, followed by the upper quartile at 63, and then finished off with our upper extreme of 79. Now, this number line, you can see from the notes, I just made it myself. All right. On the lab for this, what's going to happen is you're going to have some questions where they want you to find the 5-number summary and then see which is the correct scatter plot, which means that it's already been made and you're having to check to see if the 5 numbers are marked correctly on the line, if the 5 numbers are correct, and then, you know, so on and so on. But if I were making you do this by hand, like on paper, and if you had a question that said graph this and they didn't give you a number line, you would just have to kind of set this up on your own. So what I did was I looked at my lower and upper extreme and I saw 34 and 79, and I was like, okay, well, I need a number below 34 and a number above 79. So I just used 30 and 80. And then I was initially going to go up by tens until I realized, like, well, that's too vague and it's not really accurate for some of these numbers. So then I went back and I put the 5s in. So there you go, number line. So a couple of things. Again, these are just the points. Now we got to finish off the rest of the diagram. So number 1 for the graphing, or to finish it off, not for the graphing. The box goes around the quartiles. So you put that on first. All right. The box goes around the quartiles. The median gets a line through it. And then the extremes get connected with what's called, or what used to be called, whiskers. All right. And it looks like that. So people that use these in a profession, first of all, I can't think of anybody that does. They would probably have to work in statistics some way, right? Maybe for baseball teams or whatnot. But people that work in statistics that use these, you wouldn't even have to like label it. You just need to slap it on a number line and they're like, oh, okay, that's what all these mean. Boom, there you go. So for us, as long as we can just get it built to the point where we can check it, we'll be fine. Now, you are going to need to, whenever you have one of these questions on the lab, You are going to want to make one for yourself for each of the questions, mainly so that you can get an idea of what it's supposed to look like, and then you can check it against the ones that they give you to see which ones are right or wrong. All right, so any questions about this box and whisker plot? All right. Nope, that one. Okay. Scatter plots. Scatter plots are much easier than box and whisker plots. There are three kinds of scatter plots. You have, I do that every single time. You have positive ones, you have negative ones, and then you have ones that are either no relationship, or actually I think the book and the worksheets call it no correlation. I just always have trouble spelling correlation, so I just kind of, like, hey, relationship, there you go. Well, and two, when I taught this in public school, I always called it no relationship anyway. So old habits are hard to break. Okay, so let's see if I can do this without breaking something here. I'm trying, for the video, I'm trying to get zoomed in on the graph board over there. May not work, but we will see. Oop, wrong way. That's probably good enough. Okay, so over here on the graph board. All right, so we have, like I said, we have three different types of scatter plots. We have positive, negative, and no relationship. The first thing that you need to know about all scatter plots is that they are all in quadrant 1 on the coordinate plane. So you're not even going to be using the rest of this right now. All scatter plots are going to be in quadrant 1. Okay, the definition for a positive scatter plot says as the x variable increases, the y variable increases. So what that means is you've got your x-axis, you've got your y-axis. The values along your x-axis are going to be increasing, and the values on your y-axis are going to be increasing as well. And when that happens, you get scatter plots that look like this. And this is going to be rough, but it'll work. All right, see how it's going up to the right? Okay, that is a positive scatter plot. All right, both values are increasing, which makes, if you're going to try to put number values to it, you got like, or not number values, ordered pairs, sorry. So you got like 2, 4, you got like 4, 5.5, 5, 6.75, and they're not going to continuously go up, but overall they will increase as the other one does. All right, so that's positive. All right, the next one, shoot, I didn't mean to erase that. The next one is negative. All right, so remember why I left that marker over here now. That's one of them old ones that'll put you on your butt. All right, so negative. As the x variable increases, the y variable will decrease. Okay, notice something about the positive and negative ones. What do they both have in common? Positive and negative relationships, what do they both have in common? The x variable is going to increase on both of them. That's because most of the time with these, the x variable is a unit of time. Months, days, years, things like that. So what happens then is you get ordered pairs or points that sort of look like this. They start out higher and then they go lower as you move to the right. All right? So when that happens, you get ordered pairs like, see, this is like 322, 421, 617, course, you got 619 as well, but you get the idea. X is still going up, Y is going down this time. Now, just because it's negative, it does not necessarily mean that it's a bad thing. There's plenty of things that happen in everyday life or out in nature that would make a negative correlation. For instance, you fill your gas tank up. As you drive, what happens? The more you drive, your distance or your mileage goes up, but your amount of gas in your tank goes down. That's not negative. I mean, not generally, but you get the idea. Now, the last type, the book calls it no correlation. I always called it no relationship because, when I first started teaching it, that's what it was called. So with no relationship, you're going to have a couple different examples. All right. So you might have one, more often than not, it's just going to be some random, indiscernible spray pattern that you're not going to say you can't say that's negative or positive, can you? No. Other times, they may try to trick you by giving you one, say, that looks like this. Straight up and down. That's not a relationship. Whatever is going on with the x's has no bearing on whatever y is going to be. All right? Or vice versa. Yeah. Whatever's going on with y is not going to determine x. I said that backwards. Sorry. Or you got one, they'll give you one that looks like this. It's more horizontal than vertical. Can't do anything with that either. I've even seen one where they wanted you to tell what kind of a relationship it was, and it looked like this. It made a parabola. Can't do anything with that, right? That's a non-relationship either. You're probably not going to see one like that. I would almost guarantee it. But I have seen ones like that before that are kind of, iffy. All right, so let's look at some examples of things that would cause these relationships. All right, and these came out of the book. If you wanted to look in that area, you can. But, so this one was comparing the average temperature change from January to June. So remember, scatter plots are always measuring two variables, okay? In this one, you got your months and you got your temperature as variables, right? And remember we said that for the x-axis that you always want it to be your unit of time if they give you one, okay? Sometimes they'll give you 2 units of time, so you just kind of have to be careful there. But yeah, your months are your unit of time, and it just said from January to June, so you just do, literally just write out those 6 months. And then in the table, it told you, like if you're going to make this out of a table, it would tell you like, here's the date, here's the temperature, blah, 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 blah. Now, if it was just to say, make a generic scatter plot showing this relationship, this is pretty much what it would look like, right? Because we know what happens from January to June. Starts out cooler, gets warmer as you go to June, right? And then of course, when you get to like May and June, it kind of plateaus off a little bit. But in general, this is a positive relationship, right? Starts out low, gets higher. Positive relationships always go up to the right. Whereas negative relationships always go down to the right. Okay? I took this one out of the, forgot to switch this back. I took this one out of the textbook mainly because in years past, people have always argued about this one. So I just kind of like to use this to make sure it's covered. The altitude on a mountain hike and air pressure in a tire. Okay? So 2 things happen, among several things, but 2 things can happen when you go from a lower altitude to a higher altitude? First of all, what happens to the temperature? It goes down, right? When you go, the further you go from the surface, the temperature gets colder, right? And cold air is because the air is not moving as fast, right? Now, what causes air to move fast? Well, could be anything, but mostly heat, right? And then a lot of that heat is generated from the particles colliding together. Well, if it's cold, they're not moving, and it's also because the further that you get from the surface, there's less oxygen, right? Less oxygen means less oxygen molecules, which means thinner air. And then if you have thinner air, you have low air pressure, right? Think about like an oxygen tank, right? If an oxygen tank that's almost empty versus one that's been overfilled, which one has the most pressure in it? The one that's about to explode, right? So as you go higher up in elevation, the tire pressure, let's say that you've got a bike with you, the tire pressure is going to go down, 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 down. Think about this. Cold morning, you go outside and you have a car that has tire pressure sensors in it, and you get a warning on your dashboard that says, hey, you got low pressure in this tire back here. Has that ever happened to y'all? Oh, that's right. Y'all are younger. Well, it's happened to me several times. But as you start driving, you get that air moving and it goes off because you got that pressure going. So yeah, as you go up in elevation, tire pressure is going to go down because the air is thinner. Okay, no relationship. A person's height and eye color. There's nothing, right? I've got two younger brothers. I'm the only one with brown eyes. They both have blue eyes. One of them is shorter than me. The other one is taller than me. So you can't, there's nothing here. It's not like Game of Thrones where, you know, whatever country you're from determines your hair color. That's just, yeah, I know. Like all the ones with white hair came from here. All the ones with red hair came from here. All the ones with black hair came from here. Yep, could be. We're not going to that yet. All right, but anyway, so anything that, whenever you have two sets of data that don't have any effect on each other, it's going to make a scatter plot that has no relationship. All right, go to your textbook file. All right. Now, over here on the left where the menu is, when you first click on it, it's going to pull up a picture of every single page. There's 760 pages in this thing. You don't want to try to go through that to find what you need. So click over here underneath this where it brings up like the little table of contents. Okay? Now it's got it broken up into units. Go to Unit 3, Probability and Statistics, and expand it. And for now, just go to Section 5. Yeah. Okay. And then go to 5E, Correlation and Causality. And there you go. That's what we need. You didn't have to fish your way through the book. All right. So we're going to scroll a little bit to find what we need here. So it talks about correlations. All right. So here's a couple of examples of correlations. There is a correlation between the variables height and weight for people. That is, taller people tend to weigh more than shorter people. Even if neither one of them is classified as overweight, taller people are heavier than shorter people because of their bone density and their mass, bone mass. There is a correlation between the variables of demand for apples and price of apples. That is, demand tends to decrease as prices increase. One goes up, one goes down. That's negative. There is a correlation between practice time and skill among piano players. Those who practice more tend to be more skilled. And a concept I cannot get my daughter to wrap her head around. Because it's always, do I have to practice? Yes, you have to practice. It doesn't just come to you. Okay, so this is a table that they pulled from movies all the way up to 2012. All right, and what they looked at was two things: how much it cost to make them and how much money they made. All right, so production cost versus U.S. gross receipts, how much money you brought in. So you got ones like this one here, which I know everybody's not as big of a movie nerd as I am, but this movie, John Carter, is still to this day considered one of the biggest financial flops ever made. Disney spent, I think they actually might have spent more than $300 million on this. For some reason, I think it's like 330. I don't know for sure. But they spent $300 million on it. It made 66. That is pitiful. And it's not because nobody knew it was coming out. God knows they advertised this thing to death. But still. And then you got ones like this one. Now we know by now, because we're well past 2012, we know that Avatar has crossed the $1 billion mark. Point is, there's not really a deciding factor that says the more money that you spend on it, the better quality it is. And that is exemplified if we go to look at its scatter plot. Okay? So here's the scatter plot for it. All right? Ooh, that's too far. Well, no, that'll be all right. Okay, see how it's kind of all over the place? If you were kind of looking at it, you might be able to say that right in this area here is sort of a positive, but you can't look at it that way. You have to look at it as in terms of the whole thing. And if you're looking at it and you're going, well, it's kind of negative, it's kind of positive, that usually means it's neither one of those things. Okay? So yeah, this would be considered no relationship. Okay? Nothing there. Now, one more before we go, and just remember where we are on Wednesday. All right. This one over here. This is the weight of a diamond and how much it's worth. All right? So however much its weight is measured in carats, and notice how nothing below 1 carat has any value. Isn't that weird? That's also kind of offensive. But anyway, the heavier it is, the more value it has. I like to think back to, and y'all may not have seen this movie because by this year, it would be considered an old movie. But has anybody seen Batman Forever from 1995 with Jim Carrey and Tommy Lee Jones, where Jim Carrey played the Riddler and Tommy Lee Jones played Two-Face? There's a scene where they're stealing diamonds, right? And Jim Carrey's Riddler is not much of a criminal. He doesn't really know anything about this. They're stealing diamonds. Jim Carrey pulls out one that's about the size of like a pea. And he has to get out this big magnifying glass, and he's like, here's a good one. And then here comes Tommy Lee Jones with one that's the size of his hand. And he says, no, here's a good one. All right? So yeah, the bigger it is, the more valuable it is with diamonds, unfortunately. Like the one on Titanic, that whole necklace was just diamonds. And then the lady threw it in the ocean. But anyway, that's a whole other thing. But
yeah, I would have gone that. I would have threw her in the ocean.
I'm waiting for the parody of that where it's like a deleted scene where she drops it in there, and then here comes Bill Paxton no! And he just jumps off the back of the boat going after it. But anyway.
You're going to go in the water anyway.
Yeah. Okay, so we'll stop here. We'll pick back up on Wednesday, finishing up on scatter plots, and we're going to be doing some practice problems with 5-number summary, and we're also going to finish up looking at not really scatter plots, but scenarios that you would have to make a scatter plot with. All right? See y'all on Wednesday.